Hello everyone. Today we are starting an important and foundational topic in mathematics, set theory. A set is a well-defined collection of distinct elements. For example, A is equal to 1, 2, 3 and 4. If X belongs to A, we write it as X belongs to A, and if not, X does not belongs to A. Representing sets. There are two main ways to represent sets: roster form, list all elements, A is equal to 2, 4 and 6, set builder form, use a rule, B is equal to X where X is a prime number less than 10.
Sir, which form is better?
Each has its use. Roster is simple and visual. Set builder is great for large or infinite sets. Types of sets. Let's explore the different types of sets. Empty set has no elements. Singleton set has only one element, for example, 5. Finite set has finite number of element, for example, 1, 2, 3. Infinite set, X where X belongs to N. Equal sets have equal number of elements, for examples 1, 2, 3 and 3 to 1. Definition of subsets. A subset is a set where all of its elements are also present in another, larger set called the superset. In simpler terms, if every item in one set can also be found in another set, the smaller set is a subset of the larger one. Example, let's say you have set A equals to 1, 2, 3 and set B equals to 1, 2, 3, 4, 5. Since all the elements of set A, 1, 2 and 3 are also present in set B, set A is a subset of set B. We can write this as a subsets B. Definition of power set. A power set is a set containing all possible subsets of a given set, including the empty set and the original set itself. It's essentially a set of sets. Example, if A equals the set containing the elements A and B, then the power set of A, written as P of A, would be the set containing the empty set, the set containing only A, the set containing only B, and the set containing both A and B. Formulas related to sets. Here are some useful formulas. Total subsets is equal to 2 is to the power n. Proper subsets is equal to 2 is to power n minus 1. Subsets of size R is equal to C n comma R. Total subset is equal to sigma C n comma R. Non-empty subsets is equal to 2 is to power n minus 1. Power set cardinality is equal to P. A is equal to 2 is to power n.
Sir, can you give an example?
Sure. If A is equal to 1, 2, 3, then total subsets is equal to 2 cube, which is equal to 8. Hence, proper subsets is equal to 7. Let's go through the basic operations one by one. Union of sets. We say A union B when we are referring to all elements that are either in set A or in set B or in both. It is written as A union B intersection of sets. We say A intersection B when we are referring to the elements that are common to both set A and set B. It is written as A intersection B difference of sets. We say A minus B when we are referring to the elements that are in set A but not in set B. It is written as A dot minus B complement of a set. We say complement of A when we are referring to all the elements that are not in set A but are in the universal set. It is written as a dot complement.
Sir, how are they drawn?
With circles for sets and a rectangle for the universal set. Shaded areas show relations. Union of sets. We say A union B is the set of all elements X such that X belongs to set A or to set B. In notation, we write A union B equals the set of all X such that X belongs to A or B intersection of sets. We say A intersection B is the set of all elements X, such that X belongs to both set A and set B. In notation, A intersection B equals the set of all X such that X belongs to both A and B. Difference of sets. We say A minus B is the set of all elements X, such that X belongs to set A but not to set B. In other words, A minus B equals the set of all X such that X belongs to A but not to B. Complement of a set. The complement of A is defined as the set of all elements in the universal set that do not belong to A. In notation, complement of A equals universal set minus A. Cardinality of union. If you want to calculate how many elements are in A union B, the formula is number of elements in A union B equals number of elements in A plus number of elements in B minus the number of elements in A intersection B. Now let's learn the important properties of sets explained in a way that's easy to say and understand. Commutative property. This means the order of sets doesn't matter when performing union or intersection. For union, A union B is equal to B union A. For intersection, A intersection B is equal to B intersection A. Associative property. This tells us that grouping doesn't affect the result when we combine three sets. For union, A union B, then union with C is the same as A union with B union C. For intersection, A intersection B, then intersection with C is the same as A intersection with B intersection C. Distributive property. This shows how union and intersection work together. For example, A intersection with B union C is equal to A intersection B union A intersection C. Similarly, A union with B intersection C is equal to A union B intersection A union C. Identity property. There are two identity elements. For union, A union with the empty set is equal to A. For intersection, A intersection with the universal set is equal to A. Complement laws. These are about how a set and its complement behave. First, A union with complement of A is equal to the universal set. Second, A intersection with complement of A is equal to the empty set. That is all for this video. Jai Hind.